So here we have the controller for the operation, and inside the controller is a number of different components. The most important component being basically the brain of the operation. We're using a Linux-based Raspberry Pi. So the Raspberry Pi houses the software and the logic that's driving these micro relays. The micro relays are controlling a number of things like contact closures for humidity, to bring on the humidity, bring on exhaust fans, bring on lights, grow lights, area lights, photo lights, things like that. That's actually all being managed through software, through microcontrollers. Over here we have power supplies. We have a 12-volt power supply and a 5-volt power supply bus. Some of the components that are in here are running on 12 volts, like our exhaust fan and a few other things. Coming out of this Raspberry Pi and through the use of structured cabling, Ethernet cabling, we're actually feeding this doser/sensing component here, where we have a scrolling LCD screen that's actually reading out the various stats that we're reading. Down here we have a number of different sensors that are recording water temperature, water pH. We're monitoring the electrical conductivity of the water, the oxygen reduction, and the dissolved oxygen of the water. So we're kind of keeping track of the condition of the water. The readings that are in the water actually drive the processes as it pertains to these peristaltic pumps and the various substrates that are on this here shelf here. So from left to right, we have pH down, pH up, nutrient A and nutrient B. If the pH reading drifts too high, it'll initiate the pump to dose the reservoir with pH down and bring the water back into balance. We want to maintain that 5.2 to 6.2 pH reading as far as the pH of the water. The second function is going to actually be driving the pH up pump, where if the pH gets too low, if it drifts down below the 5.2 reading, it's going to actually put in a little bit of pH up to bring it back up, make sure we're at least at 5.2. The third pump would be nutrient A, and that's being driven by the EC readings. So the electrical conductivity meter is measuring the water, converting the EC, electrical conductivity water of the water, into a parts per million reading, and allowing us to keep track of how much nutrient we have in the water. If it gets too low, it'll initiate one of these pumps to actually dose nutrient A and nutrient B. We got a camera that's monitoring the plant and the plant growth. Every 2 hours or so, the function will actually shut down the grow lights, bring on the area light, take a picture of the plants, and this allows us to create a time-lapse video of the plant growth cycle for our records and for our reference. We also have the whole grow processing system is actually being put forwarded so that we can output it so that we can actually we can monitor our system via our phone or via our web app. This dashboard is just a customized interface for allow us to monitor the various components of the environment. I have some widgets that are just kind of keeping track of the air conditions on the top here, air temperature, humidity, dew point, and vapor pressure deficit. I have an asynchronous graph that allows me to see over time, where I can kind of visually recognize any abnormal changes for water stats like pH, EC. If I want to add a little bit of nutrient, I can input through my interface here. Say for example, I want to add 10 milligrams. You'll see that it'll actually dose the system with 10 milligrams of nutrient as commanded. So that allows me to, at will, interact with the system. Turn lights on and off, things of that nature, right through this interface and through my phone or through an app or anywhere else that I'm accessing the system. One of the most important things about having a software-based control system is it simplifies the process of growing it. It allows us one individual to be able to actually manage and grow a lot more with less labor. You can imagine how much of a challenge if you just look back at this graph at how many times this has been dosed over the course of a day just to keep the pH within a balance. To do it manually, whereby have a person coming in and using devices like an EC meter, testing the water and making adjustments accordingly, where it would be very cumbersome and labor intensive, where with a system like this, you can actually set it and forget it, and it will do those functions day in and day out, hour in and hour out, just constantly dosing, waiting 5 minutes, taking another reading. Oh, we need a little more, dosing it. to have a person doing that would be very cumbersome. Additionally, when you're not around your system, the benefit of having it set to send you email alerts and things like that so that you can take action remotely is a strong benefit of having your process automated.